Thank you, everyone, for coming out. This is the second talk I've given today, and some of you may or may not have been in my previous one. The reason for that was just another speaker dropped out, so they I had a few presentations in my back pocket, so they asked me to do another one. So this was the main one. This talk is going to be very practical and very hands-on oriented. So it's really meant to give you something to walk away from. It's kind of an interesting scenario. The lights here are so bright, I can't even really see the audience, or how many of you are sitting here. So you can see me, but I'm kind of blinded. Maybe that would be better for stress and emotion or whatever. But yeah, let's just dive in. Okay, so my name's Brad. I've been working in artificial intelligence for about 6 years now. So I'm not like a industry, gray-haired industry veteran. I'm actually rather young. I've been doing software though for quite a while, and I came into this from the background of full stack engineering and just doing front end and back end and really trying to solve tough problems. And ultimately, artificial intelligence just became one of those new tools to use when I'm solving problems. So, we're in the era of big data. I think that's unquestionable. Funny enough, when I actually first gave this talk, it was not it. It was on an AI-focused conference. So this is actually much more relevant today, because we're actually at a conference literally called Big Data. So there's lots of tools right now for building and processing very big data sets. And there is a lot of big data available for building artificial intelligence solutions. Certainly, if you're in the field, you're aware of ImageNet, very large data set of images. There's nothing that even comes close. There's Coco, but it's not nearly as large. There's Wikipedia. In theory, if the planet went to shit, and all civilization is destroyed, but you happen to have a copy of Wikipedia, you could probably do a pretty good job rebuilding civilization. There's a lot of knowledge in Wikipedia, so that's big data, arguably, very, very large. It's gigabytes. If you've ever tried to download it, it takes a while because their backup servers are very slow. OpenStreetMap, if you're looking for geographic data, and there's many more. Common Crawl. Common Crawl is a data set where basically they've just taken all the websites on the internet that they can get their hands on and assembled it into big data sets. But you'll notice that a common thread with the free big data for artificial intelligence is it's all just data that was put together often for another purpose. ImageNet is an exception here because that was a purpose-built data set. But say Wikipedia, Wikipedia did not come into existence for our AI needs. It was there for another purpose, which is humans' need for knowledge. And so when you're really trying to build novel and different AI solutions, when you're really trying to go out into new territory and really try something different and to change the game, the first thing that you're going to find as you try to build, say, your AI startup or your new product, even at a large company, is the data is really not easy to get. It's sometimes raw data is available in some cases, but there's no. If you're trying to build an AI accountant, for example, there's no tax advice data set you can just download from Kaggle and apply, run your model on it, and 2 weeks later you got a product, an MVP. That just doesn't exist. If you're trying to build an AI that is like a personal assistant, the Google device that talks to you, or Amazon Alexa, there was no data set that Google could just download and apply on their speaker. They had to build that data set from scratch. Financial auditing, I guess that's kind of accounting as well. Recruiting, if you're trying to build something that, say matches, resumes to job descriptions, or you're building a tool to analyze people's careers, you're not just going to be able to go on Kaggle and just download a recruiting data set. It just doesn't exist. You know, when we're building artificial intelligence solutions, more often than not, and it's not always true, but more often than not, you're building the data set from scratch. Like, you might have some raw data, but you're going to be labeling it yourself, and it's a process. And so, you know, someday, eventually, and I think this is probably the dream, is that, you know, we'll have an algorithm that's just so magical, so good, a neural network so powerful that we can just, you know, we'll feed it, you know, every university textbook ever written or created, you know, feed it every speech, and it'll just come out and it'll know everything. You know, it'll be able to answer every question, it'll be able to do any task, and just simply by feeding it a book on, say, accounting, it'll become an accountant. Wouldn't it be nice, actually, if it were that easy? Humans aren't even really very good at that. You give a human an accounting textbook, that won't make them a very good accountant. It'll just, you know, give them some basics. So we want this magic algorithm. I would love to invent the magic algorithm, but that's not what we have. You know, today, when we're building AI, more often than not, you're building it from scratch, and the entire success of your product almost depends entirely on the size of your data set. You know, if you're able to get, say, 100,000 samples together, and then the next person was only able to get 10,000 samples, you win. Your product is at the, say, 98, 99% accuracy threshold. Their product's sitting down at 80% because their data set's just so much smaller and so much more challenging. So I really want to give you very hands-on, very practical tips on how do you get to that and manage and construct that data set from scratch. So the first and probably most obvious tip, when I talk to a lot of AI startups, I've tried to create my own AI startups a couple times. I've had helped and advised other people with building AI products from scratch. It's usually, it's kind of sad actually, but in a way, but you often don't actually have any AI, any machine learning, not even one model in the beginning. What you start with are humans, and humans can do the task. Say if you're trying to build something that detects cancer, you'll have real human doctors, and those real human doctors will go in there and, you know, manually label images. So the approach that I'm usually recommending is actually start on, if you're building a new AI product, just launch, like with no tech, none whatsoever, like, or very minimal tech, and actually just have humans in the background doing the processing. In many cases, some clients will be like, yeah, like you can't really do that, or it's very difficult because, you know, we have this real-time expectation. But if you think about it carefully and really plan ahead, it's not so difficult, and you'll find, and you know, in a lot of these cases, it's very easy to build that human-in-the-loop solution while preserving, say, a real-time requirement and, you know, say a $5 per sample, you know, limit that you have. You know, chatbots. If you've ever built a chatbot, you probably know this. It really starts as a chat human. It either starts as a chat human or it just starts as a really shitty chatbot because you manually entered like 100 samples. A lot of these chatbot platforms, they kind of suck because they insinuate that you can enter, say, 100 data points. Dialogflow is actually hideous. So many people I meet, and they're like, "Oh, I tried Dialogflow and it didn't work very well." And I'm like, "Well, how many, you know, entries did you put in your data set?" "Oh, it's like, I typed in 10 or 15." I'm like, "Oh, 10 or 15. Oh, I wish it was that easy. Like that would be wonderful." But it takes way, way, way more data than 10 or 15 samples. So they'll either start with just like a really shitty chatbot that doesn't work, and they'll label the data as they go, or they'll actually have humans there ready at like a customer service department, like a contact center or a call center. They just have they set it up with humans in the beginning, and gradually the chatbot approaches the accuracy of the human as your data set increases over time. Tax preparation. We have a company here in Toronto that's doing tax preparation. actually, the more interesting company is they're doing AI auditing, and it's no secret. You tell your customers, you go out and you're like, oh, we have all of this amazing technology and this magic algorithm, and often like the hidden fact is it's like there's no AI at all. There's just people behind, and they just have like a really good process that makes it very seamless and magical, but there's in fact no machine learning algorithm at all. AI contract analysis, in a couple of cases, so okay, I saw one law firm where they actually had historical data on their contracts, and they actually, it was in a way that the labels came for free. But most of the time when I have worked with people and advised them on building contract analysis solutions, it's like we gotta build that data set from scratch. Like we gotta label the data, and we're often getting some like very professional lawyer to teach some very non-professional people or unskilled labor basically to go through these contracts and label it. So you start with humans. It's not magic like that, but that's the way to get really good quality data. Have a dedicated data set team. This is actually really important. So when I meet a lot of machine learning people that are really building novel solutions, often getting good labeled data is like an afterthought to them. It's like, oh, we've got like 10,000 images, raw images. I'm just going to fire them off to India, and the Indian people will come back with labeled data, and then I can work on my algorithm. And it makes sense as a data scientist or a machine learning engineer. You love digging into the algorithm, like getting into that neural network and playing with it and testing different approaches. Oh, that's so fun! It's so satisfying. But it actually, if you're building a product from scratch, it really has very limited impact on your success. In fact, that thing you wanted to outsource because it's such a headache is more important to your success as an AI product than the thing you want to focus your time on. You want to focus on the algorithm, but the data that goes into that algorithm is 10 times more important than the algorithm itself. So what I'm recommending to people is actually, this is a real function. It's not something that you give to a machine learning engineer and just let them outsource it, or just, we're going to shove that to a side. This should be a real team internal to your company where the people you hire become specialized on the type of data that you're working on. They come to understand the problem. They can label a sample in seconds or minutes rather than say 30 minutes if you go to an outsourcing firm. They understand what are the gotchas, so they're not putting bad labels in place. And there's an additional advantage when you take that labeling process and really bring it internally. Yeah, okay, hiring locals, in Toronto, we might have to pay someone $25 an hour, versus if I go to some Indian BPO firm, I got to pay $5 an hour. That would seem like that's a lot better, but actually, having that internal team has advantages. And one of the biggest advantages is they can monitor the algorithm, and they can provide feedback on what's working and what's not. When they sit and they're close to the engineers and they're talking with the machine learning engineers, it's like, here's what I'm seeing. They can view what the results of the algorithm are on totally new samples. Like that's their job. Literally, is continuously. Here's a receipt. Here's the name of the receipt and the merchant name, and here's item 1, here's item 2, or whatever your labels are. That can be quite a variety of labels. I found that they provide me personally a lot of insight into the types of mistakes that the algorithm is making, where we need to collect more data, where we need to collect less data, where we're fine in this area, but we're kind of poor in this area. For example, we found that we were really good on English-speaking receipts. I'm not getting into the background of that problem, but basically we had to pull data off of images of receipts. And we were really good on English ones and really bad on French ones. And we actually had no way of knowing that until the data team kind of brought it up and said, actually, the algorithm is working very, very poorly on these non-English receipts. And because we had we never labeled a receipt as English or French in our data set. We actually just didn't know. Like, we had no way of measuring that. Until a human brought it up to us on our data set team, we would have never known. And so having a dedicated data set team has a lot of advantages. And similar to that, just sometimes you got to scale up quickly. I get it. Like, you've got 1 million images, and you need labels on all 1 million images in a couple of months, because you've got a project and that's due in 6 months. That's hard. And sometimes people, even when they know what the best practice is, that they know they should do it internally, they still prefer to go to the Indian firm or the, now actually there's I see Chinese companies messaging me about this. I see some companies in South America that are doing these outsourcing services. But the problem with the outsourcing your data is that they don't give a shit about quality. Like, they really don't. What they care about is getting the data to you in a way that it appears like they've done a good job. And so, like, one of the experiences that I've had with outsourcing the labeling of data is I will talk to the manager of the company, and I'll explain to them, okay, we have these 5 labels, and we need headers labeled, but not the body, and it has to be labeled in this way, but not that way, and we'll be very particular. And the manager successfully understands. Like, they understand. And so we'll send them, say, 100 documents. They'll get them labeled, and they'll send them back to us, and they're like, please check these, make sure the quality is good, and I'll go through it. I'm like, wow, these are great. These labels are all correct. That's wonderful. And but then you send them the 10,000 documents that now it's the full project, not just a POC, and you send them 10,000 documents, and you get back the 10,000 documents, and you find out that they're labeled like shit. Like, there's a ton of errors and mistakes and really just crappy labels in there, and you're like, oh, like, what happened? Like, they did the first 100 so perfectly, and they did the next 10,000 so terribly. Well, first, there's a bunch of factors at play, but ultimately what happens is you were able to successfully explain to the manager how to label the data, but that manager did not communicate that to the much larger team of people who have to label the data in general. And so when that manager double checks the data, of course they correct all of the mistakes before they send it to you. But when in that first 100, especially if that's pre-sales, they do 100 documents for you because they want to close the deal with you and they want to prove that they can do the job. Of course, they're going to focus and make sure those 100 samples are really good quality. But they really don't care about the 10,000. And so they'll just be that manager might give 30 minutes of instruction to the labeling team and then just send them off, and you get back 10,000 documents, you're like, wow, these are really crappy labels. Like, how can there be such a, every time the manager sent us test samples, they looked great, but then the entire data set, shit, what's happening? Well, what's happening is they just don't care about communication. What they cared about is, they don't care about quality. They cared about closing the deal with you and getting the job done as quickly and cheaply as possible. So these outsourcing firms, be very careful with using them, and you got to check everything. Not sampling 1% of the samples. You got to double check 10, 20, 30% of the data you get back from labeling teams in order for it to work. If you're going to go this route, there's a lot of these companies that are now dedicated on AI labeling, and I would focus on those instead and using those. Crowdflower has actually been renamed. They're now I think they're called Figure 8 or something like that. Playment, now there's a whole bunch of them. The companies that are the only thing they do is labeling data, they have a much better idea of just how important the quality is. And now to totally contrast and refute myself, you can, in some cases, definitely not all, but you can in some cases actually use very noisy data and still accomplish your machine learning objective. There's a lot of deep learning techniques that are getting very good at using noisy labels. As long as there's even a slight bias towards the correct label within the data set, the algorithm will learn. These noisy data presents a big challenge for measurement of accuracy. If you have 10% errors in your data set, for example, and you measure your accuracy, and you're at 90% accuracy, well, you're probably close to perfect, but you wouldn't know it because there's 10% errors in your data set. So noisy data can present a challenge on the measuring side, but actually your model, especially deep learning, is remarkably good at seeing through the noise and still finding the pattern that you wanted it to find. So even though you measure the accuracy at 90%, in fact the model has learned a near perfect interpretation of the data, and that's good. And there's a growing body of work on how to use noisy data, reducing your learning rate and batching things differently. Then there's actually different types of layers you can insert. So there's a lot of work there, and so just consider that. Build your own data tool. Probably the most valuable and useful lesson that I've learned over the last several years is the data and the way that you construct and put apart the labels for your data is so very close to the problem that you're solving. So building your own labeling tool, like you can go on GitHub and you can find dozens of programs that will let you put bounding boxes around an image or slap a label on text. But that annotator makes a big difference. If you're able to take what is 10 clicks and turn it into 5 clicks, that can be 100% speed improvement. It literally doubles the amount of data that your labeling team can produce in the same amount of time. And if you've ever done a lot of deep learning, the difference between 10,000 samples and 20,000 samples can make a huge difference on whether your project succeeds or not. That could mean the difference between 80% accuracy and 95%. So improving that annotator is valuable. So if you don't know what an annotator is, it's a tool where you have raw data and you're just slapping a label on top of it. This is a great example. I love this one because Google basically, so smart, I love Google. They got us to label their data for them for free. Originally, they were doing it with stuff like reCAPTCHA. That was their greatest purchase ever. They bought reCAPTCHA, I don't remember what the number, but some number of millions. reCAPTCHA is probably worth billions and billions of dollars to Google because they've convinced the entire population to label their data for you for free. I don't know if any of you have done a reCAPTCHA recently where it's like, please select all of the stop signs in this image, or click all of the boxes with a traffic light, and you're just like, oh, you jerks, you're getting me to do this and you're gonna train your model on it afterwards. You get a bunch of free data. So I love it because it's so genius that they got people to do this for free for them. But that's an example. Here's another example. This is for a travel project where you're labeling just travel images. What type of environment is it? Is it winter? Is it summer? Is it beach? Is it mountain? And then once you have those labels, that can get fed into some downstream process. But you just need those labels in the first place. Here's another example. Now this is a labeling tool that's used for bounding boxes. I haven't actually used this particular tool myself, but I've seen this more often in basketball where they're actually labeling plays, that's dribbling and that's a layup and other basics like that. I don't really know many basketball plays, but this is an example. Here's another example. This is for labeling text. Typically, it looks a lot like this, where you have a block of text, and there'll be some sort of coloring that indicates what the various labels are. When I have built these labeling tools, the reason I recommend that you actually build it yourself and specific to your project is just it results in better quality data. You can often fine-tune it, reduce the number of clicks required to label the data, make it faster, make it intuitive, put keyboard shortcuts in there. You want that data labeling to go as fast and conveniently and quickly as possible. And on top of it, it often makes that human-in-the-loop process, which I talked about in step 1, a lot easier. This is a great tip. Design for continuous change. How many times have I had to actually go back and change the labels on data I had already labeled? And after we realized some Stupid thing that we just didn't realize at the outset of the project. So I'll tell you where this has happened for me. We were coming back to the example of receipts, where you take a photograph of a receipt, like from a smartphone, and now you need to turn it into structured data. Like this is item 1, this is item 2, there's the price, there's the total, there's the VAT, there's the grand total, so on and so forth. Like you have this necessity of labeling receipts. And so one of the ways we had to relabel the data, unfortunately, was around item prices. And so initially, we just had one label, the item price. But what we found over time is that receipts actually represent item price in a bunch of different ways. You can actually get unit prices. You can get a price with a discount applied, or it may present the original price without a discount applied. So initially, where we thought there was one label, later in the project, we came back and we actually had to have 6 different versions of the item price label to represent different ways of interpreting that price. So this will happen. Honestly, if you're building a new AI product from scratch, you should assume that this is going to happen. You're not going to get the labels correct from day one. In fact, if you can make it more agile and building your own annotator, it allows you to build processes and quality control so you can relabel data. If you later realize, shit, we need to take this one label and crack it into 2, or we need to add in more labels to these particular documents. Plan for that. Build that into your process. And if you're doing costing on the data and how much it costs to label, that costing should take into account that you're probably going to need to touch every sample 2 or 3 times while you're evolving the product and the machine learning algorithms that go along with it. You will have to change it. You will have to change those labels. So just plan for it, basically. Of course, double verify some data. So there's kind of 2 approaches when it comes to managing the quality of the data set. One approach is you send it to a labeling team, and you'll have some sort of manager, and the manager will sample check the data. Like every 2% or 3% of samples get sent up to the manager. The manager will look it over, and maybe they'll be like, oh, sorry, you're labeling the data in this way, but it should be this way. They'll be able to identify mistakes. But the sort of hierarchical approach, which is what I see most labeling companies actually use, it's not actually optimal. There's another way of doing it, which is what I'm suggesting here, and that is to actually compare the people annotating and labeling data to each other. And this is basically send that piece of data point to one person, and then send it to a second person, and if they agree, that label's probably good. If they don't agree on what the label should be, then you can send it to a third person, like a tiebreaker. And in fact, if it's a really complicated label, where it's kind of ambiguous what the label is, you might have a 4th or a 5th person that actually gets involved. And if you've built your own annotator, all of this can be very automatic. It just in the background, it's automatically doing it. But sending the same piece of data to multiple humans just allows you first to measure how often your humans are making a mistake, which is very valuable to know that, say, your humans are, they're consistently trained and they see the data in the same way. It also helps you to detect this problem of error amplification. So when you're building data sets from scratch, this is it's a very pernicious problem, is that once the algorithm gets decently good and it's 80 or 90% accurate, I find that the labeling team kind of gets lazy. Because, say a receipt will pop up, and they'll look it over, and they'll be like, oh, yeah, it looks good, approved. Another one pops up, they'll look it over for 10 seconds, approved. And they just kind of get lazy, and they stop looking it over, or they don't look it over in very good detail, and they start approving samples that are actually that are incorrect. And so once you start adding samples that are incorrectly labeled into your data set, of course, you get degradation of the accuracy. And so this can be really tricky when you're like, okay, we're getting worse accuracy with 3,000 samples than we were with 2,500 samples. Like, what happened? How, like, more data is always better. Like, why did these additional 500 samples actually drop our accuracy? Well, what happened is your labeling team just got lazy because your algorithm got good enough. It got good enough that most of the time it was working. And so most of the time they're going approve, 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 approve. And they're not actually looking at it in detail or catching any of those mistakes. So by sending the same data point to two different people, it can be much easier to detect this, and also just sending the data raw. Like, so rather than pre-labeling it, you can just send it to the second person and ask them to label from scratch, so that they're not modifying the computer's predictions for the label. They're just labeling it from scratch. So this double verification, it has a lot of advantages versus the sort of hierarchical, like a manager is going to sample test all of the data. Focus on the exceptions. How many times do I have to say this? Self-driving cars are probably a great example of this. There's been a lot of very negative media attention. Tesla had a car that killed some person, and now everybody's like, oh, we're not ready for self-driving yet. And I'm just like, when I look at these problems of like the car was not able to see a person wearing dark clothing in nighttime. Well, first, humans are not that good at seeing a person in dark clothing at nighttime, so that that might have been a mistake a human would have made anyhow. But probably the more interesting thing is I see that as a data set problem. When you're building that self-driving car data set, it's super easy to just put a car on the road and just record everything, drive everywhere and record everything. But you'll find that like 80% of your data is like normal driving conditions with like medium traffic, and the weather is sunny or overcast. You're getting very little data on, say, snowstorms. You're getting very little data on, say, rain. You're getting certainly very little data on people wearing black clothing jaywalking in a street in the middle of the night. Like, that's just, you don't get that in your data set. So when you're building a data set from scratch, you actually have to put more weight towards those exceptions. So, if I were running, say, a self-driving car company, I've never actually done that, but if I were, if there was like a rainy day, it's like everyone halts their work, hop into their car, and start collecting data because there's not that many rainy days. If there's a snowstorm outside, it's like I want every employee in the company getting the dash cams going, getting the LiDAR hitched onto their roof, and out driving in that snowstorm because like there's like only a couple snowstorms a year, possibly. It could be very hard to get data on a snowstorm. And you'll find this, in the case of receipts and parsing receipts. One of the exceptions that we found were return receipts. It's like 95, 98% of the time we're buying stuff and we don't return it. We enjoyed the item, we're satisfied. But occasionally, a couple percent of the time, people actually try to return the item. And so those return receipts, like we'd go out, we collected all this data, we algorithm, measured accuracy, we got 95% accuracy. We launch it into production, and suddenly we find that we're only getting like 90 or 85 in the real world because we totally didn't realize that these return receipts just look different than regular receipts. You can see this with languages. You see in chatbots a lot where it's like you have to, you code it in one language, but as your chatbot becomes more and more popular, they start talking to it in French and Italian or Spanish or whatever. From your data set's perspective, that's an edge case. So you need to over-represent. Facial recognition, another great example. In United States and Canada, where I live, only 5 to 10% of the population is black. And there's been a lot of media attention lately about algorithms being biased and not working very effectively on basically non-white people because, and there's ways you can measure that, but that can also be a data set problem. You can view that as being, well, if only 10% of the population is black, if I collected a data set perfectly evenly for facial recognition, I'm going to get mostly white people and only a handful of black people. Like the data set itself is biased. And so you actually have to focus more effort on collecting data of those minority races in order for your facial recognition algorithm to work consistently. They need and less attention on, say, the default case, which for us would be standard white person, basically. Always include production data. Definitely. Like, especially when you go out and you collect data manually, you're introducing subtle biases into your data set that are really hard to even know about. So you may spend 6 months, you collect a bunch of data, you build a model, you put it into production, and you tell all your customers, oh, we get 95% accuracy, or we get 98% accuracy, it's close to perfect. And as soon as they're making their very first API calls and they're telling you, oh, this is shit, like this thing barely works, like works only a third of the time. How can you say it's 95% accurate? And I'm saying it's only, I'm only seeing 30, 35%, like it's mostly crap. Well, what happens is the way that you collected that in that initial 6 months, the way you built the data is actually just different than the real world data that your customers are sending to you. So you can't rely on your own data collection processes exclusively. You have to have a human in the loop. You have to have that production real world data getting labeled and fed back into the algorithm. That's the only way to get good accuracy on real world data. You see this particularly in chatbots. Like you can spend to the hills typing out 1,000, 10,000 different ways of asking a question, for example. And as soon as you put the chatbot into production, someone's going to ask it in a way that's never been asked before. Like that just always happens. I've never seen a case where production data is identical to manually collected data. So just always include production data. Always have a process. Sometimes it's very difficult due to privacy concerns. Google, Facebook, they're getting a lot of flack because they labeled voice data, and they had processes where, to me, is a best practice, but now they're getting a lot of flack for it, where they fed the production data back to the labeling team and back into the model, which improves the accuracy. So they're getting a lot of flack for it due to privacy reasons, but it is undoubtedly the best practice for building great machine learning and artificial intelligence. So that's everything I got. Thank you guys for coming out, and I guess we'll move on to questions.